Hello friends, this is Dr. Vader, Assistant Professor in the Department of Chemistry, Polytechnic College of Arts and Science, Solapur. In this PowerPoint presentation, we are going to see a very basic term in the science, catalysis. After this presentation, the students will able to know how the catalyst works and how should be the catalyst for a particular reaction. The contents of my presentations are the introduction, function of catalyst, requirements to be a catalyst, classification of catalysis, and the types of catalyst and catalysis. Scientist John Burgess, he was a scientist which first time used the term catalyst in the science. So, the substance or the compound which when added in reaction mixture in very small amount, it alters, changes, either increases or decreases the rate of chemical reaction without taking part in chemical reaction is called catalyst, and the role played by catalyst in chemical reaction is called catalysis. The term catalyst, actually this word is derived from the Greek word catalyst, means to speed up. So, there are different roles played by catalyst in chemical reaction. The first one, it brings the catalytic effect, means it alters or changes, that is either increases or decreases the rate of chemical reaction. It gives a specific path to the reaction. It avoids the formation of side products or any type of impurities in chemical reaction, due to which the purity as well as the quality of product get increased. It affects only the kinetics of reaction, but it cannot change the thermodynamics of reaction. Let us see first what are the general requirements and the properties of the compounds or the substance to have a good catalyst. The first one, small amount. The small amount of substance is sufficient for the production of a large amount of the product from reactants. For example, for the production of 2.5 liter of water from H2 and O2, only 1 milligram of platinum powder is sufficient. The next one, unchangeable nature of the catalyst. The catalyst may undergo physical change or physical form, but it never undergoes any type of chemical composition or chemical change. Its quantity remains the same throughout the reaction. For example, in the decomposition of KClO3, the user catalyst MnO2, it changes from its coarse nature to the fine powder nature. Next one, to start the reaction. There are number of chemical reactions which are initiated by the catalyst. For example, the reaction between H2 and Cl2 is not possible in dry atmosphere, but the presence of a very small moisture spontaneously produces HCl. The catalyst specificity is the next one. Here, the action of the catalyst is highly specific, means any one compound which accelerate or which catalyze one reaction may fails to catalyze other reaction. For example, MnO2 decomposes the KClO3, but it fails to decompose KClO4. Next one, acceleration. Catalyst accelerate both forward reaction as well as backward reaction in same extent without altering, without changing the equilibrium of reversible reaction. Next one, the catalyst nature. Here, the activity of the catalyst is highly depends upon the catalyst surface. The surface having more defects, more pores or crevices, some grain boundaries, they provides more active centers. Hence, the catalyst surface must be having some defects. It gives the more active centers, and hence they provides the more efficiency for the catalyst. Next one, promoters. In some reactions, the activity of main catalyst get increased by mere presence of some other substance. So that substance actually increases the activity of main catalyst. So such phenomenon is called promoting action, and the other substance is called promoter. Next one, catalytic poisoning. In some reaction, the activity of main catalyst get decreased by presence of some impurities in the reaction mixture or by some foreign material. So such phenomenon is called catalytic poisoning. The next one, working at optimum temperature. For every catalyst and for every reaction, there must be the optimum temperature or a particular temperature at which the efficiency or activity of the catalyst is high. On the basis of this slide, let me ask a very simple questions. How the catalyst surface should be and what are the active centers of the catalyst? The answer of these questions are very simple. The first one, how the catalyst surface should be. As I told that the action of the catalyst is highly specific and the activity of the catalyst is depends upon the catalyst surface, means the surface having some defects, some crevices, some grain boundaries, some pores, they provides more active centers. Here also one more reason is that here the small grain size on the catalyst surface or these particles having small size, they provides more surface area. Hence, as they provides more surface area, there is a more activity or efficiency of the catalyst. The second question is the active centers of the catalyst. The active centers of the catalyst means that the points on the surface of the catalyst where the reactants comes in contact, they get adsorbed, they comes in contact with each other and forms the product are called the active centers of the catalyst. Let us see the classification of catalysis. The first one, homogeneous catalysis. In homogeneous catalysis, the reactants used, catalysts used and also the products formed all are in same phase. This catalysis is called homogeneous catalysis. The homogeneous catalysis provides, it explains the intermediate complex formation theory of catalysis. Let us take an example of the homogeneous catalysis. In the hydrolysis of ester, that is ethyl acetate, here the ethyl acetate, H2O, the products formed acetic acid and alcohol. Also the catalyst used, that is HCl, all are in same phase. The next one, heterogeneous catalysis. In heterogeneous catalysis, here the reactants used, catalysts used and also the products formed all are in different phase. It explains the adsorption theory of catalysis. Here the example of heterogeneous catalysis is the production of ammonia by Haber's process. In this, the used reactants N2 and H2 and the formed product ammonia is in gaseous phase, but the used catalyst Fe promoted with molybdenum is in solid phase. Let us see the types of catalyst and catalysis. The first one, positive catalysis. The chemical reaction in which the catalyst increases the rate of chemical reaction is called positive catalysis and the catalyst is called positive catalyst. For example, the production of ammonia by Haber's process and also the conversion of SO2 into SO3 during manufacture of H2SO4 by contact process. The next one, the negative catalysis. Here in this chemical reaction, the used catalyst retards, decreases the rate of chemical reaction. So such catalysis is called negative catalysis. In this catalysis, the used catalysts are also called inhibitors or anti-catalyst. For example, here the decomposition of H2O2 is avoided by adding some drops of H2SO4. Next one, auto or self catalysis. When one or two products are allowed to react with each other and products are formed, then one of the product formed functions as a catalyst for further reaction. So such type of catalysis is called autocatalyst or catalysis. For example, the titration between KMnO4 and oxalic acid. Next one, enzyme catalysis. There are several biochemical reactions takes place in the body of plants and animals. In such biochemical reactions, the enzymes acts as a catalyst. So such catalysis is called enzyme catalysis, and that enzymes acts as a catalyst. The next one, inducer catalysis. When the reactants are allowed to react with each other, but one of the reactant, if it is inactive, then the activity of inactive reactant get increased, get induced by mere presence of other substance. That other substance induces the activity of inactive reactant. So such type of catalysis is called inducer catalysis. Last one, acid-base catalysis. In these reactions, the acids or base acts as a catalyst. Means when in chemical reaction, acid acts as a catalyst, then the chemical reaction is called acid catalysis, and when in chemical reaction base acts as a catalyst, then such chemical reaction is called base catalysis. Thank you very much.